Hello.
Hello. Someone respond, please. Am I audible? Hello. Hello.
Yes, sir,
Yeah,
you are audible. You are audible.
you are audible. Mr. Chandu, Mr. Samuel, can you listen to the host there?
Yes, yes, we are able to hear.
Yeah, Mr. Samuel, is it okay? Mr. Samuel, please. I think the admin can check for the voice connectivity with the panelist, Mr. Chandok. Admin can check now.
This is Deepak here. Can you hear me?
Yeah, this is Chandok here. Can you hear me? Pankaj, are you
Hello,
able
could
to
someone
hear me?
respond, please?
Mr. Pankaj?
Sir, admin is checking for you, sir. Please respond. Please respond to admin, sir. They are in Dubai.
Okay. Okay. Okay.
Hello. Yeah.
Hello.
Pankaj, you are audible to us. We can hear you very clearly.
This is Deepak. Can you hear me?
Yeah, I can hear you, but your voice is not that much clear.
That's mainly because there is no internet supply in Chennai because of floods, and I'm using my mobile network.
Okay.
This is JS Chandok. You able to hear?
Yeah, sir, your voice is clear.
Okay. And video is also fine? Video?
Yeah, let me check your video. Mohammed, is video clear? Yes, your video is clear, sir. Sir, I hope you are connected on a LAN internet.
Yes, yes, yes.
Okay, okay. Thank you, sir.
Can you see me? The video?
Yes, we can.
Thank you.
very interesting and important session on floating solar, which we say beyond the horizons, meaning we need to reach out all the possible areas where uh, we should use the resources for setting up of the solar projects. So today, there are certain changes because of the last minute changes from the honorable ministers. So before I invite Dr. Mathur or honorable DG, I would like to slightly give a small structure of today's program. Uh, honorable minister from Mauritius, he couldn't last minute reach here. So on his behalf, uh, the Director Technical Services of Ministry of Energy and Public Utilities will be. He has joined virtually. He'll be there. Then we have some of the panel on virtually from NTPC, uh, the Adani Green, and also from the NCSCM. We had invited him from Chennai, who have done the work in the Lakshadweep in terms of environmental and marine studies and all. And the Chennai has under flood for since yesterday. The entire the airport is closed, so he also has joined virtually. So what we would do, I will first welcome Honorable DG to give the welcome address, and thereafter then we will have the presentation and the panel discussion. The honorable ministers will be joining as and when they join. We will request them to address the whole gathering. Thank you. Thank you very much. And I invite Dr. Mathur for the welcome remarks. Thank you.
Thank you. Thank you very much, Ramesh. Colleagues, both here and online, first of all, it's a delight to welcome all of you to this meeting. We believe that floating solar is one of the answers to large scale solar generation, as the picture that you see in front of you is on a reservoir next to a power station where a very large amount of solar has been put on a lake. Is this a exception? No. There's a huge potential. There's over 4,000 gigawatts, gigawatts of potential that we see across the world. Approximately 25% of this is in Africa, where, this is only based on assessments. It could turn out to be more as we assess more. But 25% of it, about 1,000 gigawatts, is is in 700 and plus water bodies which are there in Africa, those which have been assessed. In Middle East, in this area, where there's a shortage of water, yet we have seen that there are over 2,000 water bodies where we have a significant potential in this area, which can add to 29% of the 4,000 gigawatts that we were talking about. So again, about 1,000 gigawatts in this area. In Europe, there is a challenge. We assessed 1,000 water bodies, but there is the potential is there. It's about 200 gigawatts, but it is less in terms of the total of the 4,000 gigawatts because of the demands being relatively lower. Also because uh, we don't expect that much floating solar to occur in Europe because it can occur through other uh, applications. South America, North America has a lot of lakes, and we looked at 2,250 or something of that sort, and there again over 1,000 gigawatts can be set up. South America, Australia, and Oceania, all of them have potentials which could be significant portions of meeting their energy targets. Now, having said this, let us look at both the opportunities and the challenges. We have seen that floating solar has grown rapidly. So technologically, at least as far as depths or the changes in water levels of up to 25 megawatts is possible, as long as mooring and tethering is possible. Consequently, when we are looking at the rock at the surface areas that are there next to islands, for example, it is possible before you go to the deep sea. It is possible to do mooring there. Yes, the capital cost will be more because of the needs for floats, because of the need for mooring, because of the need for more resilient electrical equipment. Because remember, you are in a warm, humid atmosphere. At the moment, the capital cost is somewhere around $1, 0.8 to $1.2 per watt of of capacity. Uh, but the delivered electricity is still in the range, costs are in the range of less than of about 4 cents per kilowatt hour produced. So it is competitive, especially when you think that most of these would be would either uh, adding on. So you have, for example, if it's behind dams, you could have solar during the day, floating solar during the day, and the hydropower during the night. Or if it is replacing diesel, for example, in islands, for example, or in coastal areas, then again the cost is much higher than the 4 cents per kilowatt hour. The short point is this is economical, even though the capital costs are higher. But there are challenges. One is, if the upfront cost is higher, we need to convince financial institutions, banks, to invest in this. They consider this a new technology, even though the over 5 gigawatts have already been installed across the world. The second is, and this is a moving target, the the presence of moisture, ultraviolet radiation, and higher temperatures that we see. All of this means that both the solar panels and, more importantly, the associated equipment, including the connectivities that are done, have to be stronger. And I look forward, Pankaj, to you talking about some of these issues. The third point, and this came up in the assessment that was carried out worldwide, is the absence of bathymetric and hydrographic data. Because you need to have the plans of the floor of the lakes in order to figure out how we will do boring. So figure out what will be the strength of the anchors that you put in to moor the floating solar. Doing good hydrographic data is at the heart of reducing the costs of making this happen. I believe that as countries, this is one of the first things that is of focus. There are two more risks that I would like to add. One is, there is the great fear of water contamination, because we are adding solar panels which have got all kinds of toxic materials. We are adding electricals. And therefore, there is the great fear that we would have toxic leaching occurring from the solar equipment, the panels and the associated equipment into the water. That's one of the things that we need to convince. It will be good if we have studies in various geographies that answer this question. Associated with this is the question of how much of the area can you use. As a rule of thumb, you need to provide enough space in between the floating solar panels to allow for movement to occur so that maintenance can occur. That boats can move through, because this will be done in areas where there is boat movement, both because of transport and because of fishing. It'll be great if these kinds of mooring is shown to attract biodiversity, particularly fish, but also they can become the source of coral formations, though they're not in very deep areas, but it is possible. I think these kinds of studies, many of these will result only over time, but I think it will be useful to make us have plans on how to move ahead. Of course, why do we need to convince countries on why we need to do this? We need to, particularly in countries that are where land is scarce, where population densities are high, we need this as a means of enabling area to be available for solar panels. We believe that this needs to be added to the area which is on land and available for solar. Second is that, whether you're speaking of uh, reservoirs of the kind that you have here, which is next to a power station, or those which are behind a dam where there's a hydroelectric power station, you have lines going from the power station to the load center, which means you can utilize that, because some time of the day you can use the solar and therefore reduce the hydropower that is going, and the existing system is already there. So there is a synergy, cost reduction, of course, but there's a synergy in the infrastructure that exists. Now, one of the issues also that we need to focus on is the net benefits as far as water is concerned. Yes, we have environmental concerns for water, but also remember that these provide shade. So the overall temperature reduces. And since the temperature reduces, the production of electricity per kilowatt of the panels also reduces. This means that the off-site generation can and is more, can be more and is more than those of equivalent on-site radiation, on-site power plants that are placed in a sense right next door. And last but not least, the view, particularly from the Maldives, is that from the Lakshadweep, is that these can become places uh, where there is water conservation also, because the evaporation is less. I believe that solar provides us a great opportunity. So I'll repeat, it provides land. It is able to produce more electricity. It takes, in many cases, not in all cases, but in many cases, it uses existing infrastructure. And it provides, the biggest advantage is it provides an opportunity to build facilities when land is at a premium. Yes, it costs more, but the cost of electricity is not. I think the biggest outstanding challenge is that of environmental impacts. And I think we need to document these environmental impacts. As these come on to the public agenda, we will start seeing more hydrographic and bathymetric studies being carried out to look at the floor of waterborne areas to see how anchoring of the mooring can occur. I look forward to this discussion, and I hope at the end of it, we will be able to get views on how to make this program more effective in the many countries which can take advantage of it. I thank you for your attention.
Thank you, Honorable DG, for setting the context and putting the opportunities and challenges in front of the panel. So, I mean, essentially the panel should be able to address all these issues so that we can move forward in scaling the floating solar. Many thanks, Dr. Mathur, for that. Now, coming to the next, the Honorable Minister of Energy from Mauritius was supposed to be here. Due to some reasons, he couldn't be here, but on his behalf, Mr. Domraj Jajia, the director, have joined virtually. I hope, Mr. Jajia, hope I'm audible to you, and if you can uh, pass on the message from the Honorable Minister, that will be great. So, am I audible, Mr. Jajia?
We are reaching the hall in 2 minutes.
Okay, you are reaching the hall in few minutes. Okay, okay.
Exactly.
That's great. So we'll wait for you physically here. So slightly change the schedule. Uh, Mr. Chandok is there online again. Chandos, he is representing NTPC Limited, one of the largest utilities in the world, who have the presence in not only in fossil fuel based power stations, but equally in solar, as well as they have done so much of floating solar. So, seeing is believing, or execution is believing, I would say. So, what I would request, Mr. Chandok. So, before Mr. Chandok, one main architect of the entire processes of international business, Mr. UK Bhattacharya also has joined probably online. I would request him to giving some remarks before Mr. Chandok giving his presentation and also sharing the video. I hope Mr. Bhattacharya is there online. If he can put few words, because he has been instrumental in setting up of many projects, not only in India and globally. He was doing so much. If he is able to join, that will be great. Mr.
Good
Chandok,
morning, Mr. Ramesh
yeah.
and respected DG sir and the August gathering. While Chandok is rearing to go, I'll just take half a minute as you suggested to say a few words. Now, to start with, that in NTPC we have set it for ourselves that will set 60,000 megawatt of renewables capacity by 2032, thereby taking the capacity of this company, which is around 75,000 today, to 1,32,000, that is 130,000 megawatt by 2032. Now, out of this 60,000 megawatt capacity, a super majority will come from solar. And when we split the solar again, the solar will be developing in two ways. One is land based, which will be either ground mounted or roof mounted. Our business will be larger on the ground mounted, and also the floating solar. As Honorable DG has already said very clearly, that floating solar has its big advantages in terms of providing you without land a possibility to set up your projects. You can have use the existing infrastructure without additional cost, thereby cost optimizing in tariff reduction. Third is incremental generation because of the lower temperature at the back panel, and also the advantage of having the unused surface of the water in for the purpose of generation, which also gives you the double advantage of reducing the evaporation loss. Having said that, I will also tell that NTPC itself had been doing a lot of research on the floater, and while it was earlier very costly, we have by our own research have reduced the cost by 1/6 over last 8 years of our own effort. Mr. Chandok, who will be speaking now, was personally involved in that, in the floater design. So he carries a lot of experience in floater design also. We are also looking at now for a possibility of designing a different kinds of floater which can take some amount of turbulence also, instead of going for only a placid area. Coming to the aspect of floating solar, the benthic material, which Dr. Mathur was suggesting, that impact on the benthic is definitely a matter of study. But so far, whatever amount impact studies have been done, since we keep sufficient gap between the floater arrays, lots of sunlight as well as other nutrients which comes from the airborne, like birds and other things, they can go there, and the diversity and ecosystem is partly maintained. But yes, a more detailed study can be carried out, and I am sure this will bring out the clarity that floating solar is not having any negative impact on the environment as such. I will now pause here and request Mr. Chundu to speak on this. Thank you, and I look forward to an interesting discussion during this session. Thank you, everybody.
Thank you so much, sir. Thank you so much for this kind words and initial words to briefly tell about the floating solar as well as the NTPC journey. And definitely, you have made my life simpler because good amount of information already basically indicated in your speech. I would first of all thank International Solar Alliance to give this opportunity to brief about the NTPC journey on the floating solar. At the same time, what we are doing in the international business. So I'll just share my screen and then definitely we will go through with the presentation. So is the presentation is visible? No, not yet. Presentation visible?
Yes,
Visible.
it's visible. Please go ahead, Mr. Chandok.
Yeah. Just make it to the.
Yeah,
So,
please go ahead.
touch upon in this presentation, my agenda is that I'll just briefly touch about the NTPC. And as you all know that we are doing a lot of cooperation with the International Solar Alliance. We are already the partner in terms of providing the project management consultancy to several countries through ISA Program 6, ISA Program 4, as well as demonstration project for SIDS and LADS countries. Third is the most important part of today is what is the NTPC experiences with the floating solar project. NTPC is current global stature is this that we are incorporated in 1974 and today we are the largest power generator in India with a 74 gigawatt of operating asset. As you see that we have the 16,000 committed manpower with a net worth of USD 18 billion. And the most important part is that we have commissioned India's largest floating solar plant of 100 megawatts at Ramagundam because this is the topic of today. Just I would like to mention this particular point here. With respect to the renewable energy, we are spreaded our wings in all across the country. In India, we are basically present in all regions of the country. And we have already commissioned 3.3 gigawatt of solar plants. You see that we are already having a pipeline of almost gigawatt, which are in the either in the implementation stage or the tendering stage. As a developer, basically providing some kind of developing support, we have already commissioned 6.7 gigawatt. So in total, if you see, we are already reaching 20 gigawatt of solar project, wind project all across the country. Now, this is a very important aspect which I'd like to mention here is that the present capacity of 74 gigawatt and additional 17 or 18 gigawatt under construction, we are having a lot of thrust with respect to the renewable energy. and we target to have a 60 gigawatt of renewable energy by 2032. And on the right hand side, if you see that not only on the power sector, but on the various aspects of the energy, be it a biomass co-firing, be it a e-mobility business, hydrogen generation, CO2 capture, energy storage. So not only the power, basically, we are going to have a integrated energy company encompassing all the aspects of the energy. It will ultimately lead to the greener world, greener India. At the same time, we as a responsible company of the country, we will be also investing hugely on utilization as well. So these are the various aspects which will lead us to the energy companies. Uh, Another very important wing of our NTPC is our NETRA, that is our R&D wing, NTPC Energy Technology Research Alliance. The floater which you are just hearing from our director project, that particular product has came from this particular center only. This is the research center of NTPC. The main aspect of this research center is that we need to do the research in the sense that not only do the kind of development of the project, technology development, at the same time, kind of demonstration, and taking it to the level of higher size so that the engineering or other teams can take up. In that, we are providing the support to our station as well. So this particular R&D center is having a two important wings. One is the technology development, other is the scientific support. The technology development primarily purpose of taking it to the new technology. It can be useful for the greener energy. And at the same time, when scientific support we are providing to the ongoing stations. Coming to the international footprint, as you can see from this slide, that we already have an establishment in Bangladesh, where we have already set up 2 into 660 megawatt of coal-based plant. And at the same time, in Sri Lanka as well, we are taking up project as well as the solar project. In Sri Lanka, in Sampur district in the Trincomalee, we are taking up of 135 megawatt of solar project, in which the phase 1 will come as a 50 megawatt, may be commissioned by before December 25. At the same time, the phase 2 will come frequently. And in Kenya also, we are exploring the possibility of solar project of 360 megawatt in a late season economic. And for that also, some various developments are happening. Now, apart from the project development, we are also very much on consultancy services. Like in Bangladesh, we have provided O&M services for 120 megawatt of gas turbine plant. Similarly, ISA, ISA PMC services we are providing. In Mauritius, we are providing the PMC services for 2 megawatt of floating solar plant in the Tamarind Falls Reservoir. And in Myanmar, we have already did the PMC for the microgrid that is in the Rakhine state, solar with the battery and the DG. Similarly, for the with the UNDP project, we have done the solar water pumping. In the Middle East, clearly several projects we are taking up with respect to the audit of the project or the O&M operation and maintenance services or the R&M advisories and such type of activities we are taking up with respect to the consulting services. I am very happy to mention here is that NTPC is a partner of International Solar Alliance, and we have been endorsed as a PMC consultant. Currently, we are already giving almost 6 gigawatt of PMC services to various countries. You can see that it is already countries in Africa and 4 countries in Latin America we are already providing. And here I would like to mention one more thing is that we have already given express intent 1 gigawatt of bankable solar project in countries. It includes both the ground mounted as well as the floating solar project. Our way of working or basically the scope of PMC consultant is that we initially start with the activities that we generally get the appointment by the host country. We generally carry out the initial studies by NTPC itself. Sometimes desktop studies, sometimes if we get the more detailed information from countries, we provide the pre-feasibility report as well. Parallelly, We prepare the document with respect to the power purchase agreement, land lease agreement, government support agreement, and we provide all the inputs to the countries. Based on all those things, if we get the go ahead, then we initiate the bid process. In the bid process, we will basically go for the selection of the developer. And once the developer is selected, award of the developer, then signing of the project document by host country. And during the process of execution, also our scope is that to do the supervision for the quality assurance so that the commissioning will be done in a better way. And parallelly, if the long-term O&M is also required, also we can provide through our partners. In another program of solarizations, as you can see that there are three themes on which we have worked upon: solarization of the building, the solar pump, and the solar cold storage. And we are the partner to ISA. And with respect to that, we have done in some 9 countries, we have developed the DPR. And in the 12 countries, we have developed the DPR, the complete PMCs. As you can see from the solarization of buildings, solar pump and solar cold storage, we have already given PMC services with respect to the execution of the project also. 3 to 4 project is already commissioned. They are already working. And the rest of the project will be commissioned by this month, end of this month itself. Now coming to the today's topic of floating solar PV technology, I definitely indicate here that everybody who is basically present here is that understand about the floating solar. Just for the understanding purposes, we see that the floating solar comprises of solar panel and modules as well as the floating floaters. The inverters and the anchoring is a very important aspect. And at the same time, the electrical systems which are basically present in this. This is broadly the floating solar components which we can means indicate in this. Going further, what is basically the NTPC experience with respect to the floating solar and what could be the way forward? We must have just a small video. This is a 3-minute video which indicates the kind of installations which we have done already. And I'll just play this video. Hope I am clear up to this point.
Yeah, it's clear, Mr. Chando. Go ahead. You can go ahead. It's very clear.
Thank you so much. If the video is visible,
Yeah, you can play it. Yeah. Yeah. Can you increase the there is no sound coming. There is no sound.
pardon,
There is no sound. Yeah.
no sound.
Yeah. Still there is no sound. Yeah.
Sharing the sound. Okay. Because,
I don't know. Can we run it from here? Okay.
I'll just run it. This pictures will be visible to.
Yeah, yeah. Please go ahead. So it will be a silent movie. Yeah, please go ahead. Slightly, if you can explain together along with that.
The 100 plant. For the first project actually. This was developed with the help of support of our R&D center. R&D center is tied up with Central Electricity Central Institute of Plastic Energy Technology. And this is going to become a 92 megawatt of commission project. we are not covering the bodies. As you see, electrical infrastructure also can transformers as well. Right? Because 25 kilowatts is plant. 25 megawatts backup. 20 megawatts for in reducing. Kerala.
Yeah, Mr.
Yeah,
Sundar.
with the presentation, I'm very sorry this voice was not linked with the video.
Okay.
Hope the pictures were clear in the video.
Yeah, some of the things which you can explain during the panel discussions
Yes.
as well. So if you briefly complete it, that will be great. If you could conclude the presentation.
I will continue with the presentation.
Yeah.
As you can see that NTPC is already basically installed 262 megawatt of solar floating solar plant, and we started with Simadri and means with 25 megawatt Simadri project in Andhra Pradesh, then in Kayamkulam 22 megawatt, then second phase of Kayamkulam 70 megawatt, and in Ramagundam as you may be seeing in the video 100 megawatt of floating solar project. In Kavas also 23 megawatt and in Oraya, Uttar Pradesh 20 megawatt. And additionally, 260 megawatt is already in pipeline in Jharkhand area. And the work is already awarded to the EPC companies. So our experience is basically that we started in 2014. It's a very small installation of 100 kilowatt in Kulam, which is basically the product from our Netra, that is the R&D center. That was a very test protocol. Parallel to that, we have developed the test protocol as well. The understanding and the learning which we have learned from that particular project is basically the drive for going ahead with the major scale of project like 100 megawatt and all those things. Because when we did the research on this particular floater, we could understand that there are several nuances or several intricacies which needs to be understood before going further with respect to the floater material, with respect to its logistics, with respect to its installation on the water bodies, with respect to its contamination of the plastic with water. All those things we could understand during the development of the R&D project. And when we started this journey, the project cost was almost means you can say 14 crores per megawatt for the total cost only. In the second phase, when we come with the second R&D, reduce it to the 7 to 8 crores per megawatt with the floater cost. We understand that these type of costs cannot be in this in any case. So we did another phase of the R&D where we can reduce the cost to the floater to the less than 1 crore per megawatt. So this was the complete journey of NTPC where from the concept to commission we have installed the floater. And when we discuss about the floating solar plant, it is very important to have a feasibility. If the feasibility to consider is very different from the ground mounted system, because here we need to understand the bathymetry studies, here we need to understand the hydrography and the soil testing, carry out the environment assessment as well, And at the same time, when we want to install the solar plant, for the purpose of anchoring and mooring, we need to do a several studies with respect to the stability of the floater, with respect to its buoyancy, as well as how to connect, whether it is to be connected to the bottom or it is to be connected on the side. All those stuff we need to understand. This is a very iterative process which we need to go through for the project designing, as well as the dynamic and iterative study we need to carry out with respect to the stability of the floater as well as stability of the complete solar panel and structure. At the same time, need to understand the wind velocity also, because for that we need to carry out the final element analysis and the computational dynamic study as well, whereby we can understand that what are the weaker portion of the floaters, yeah, which requires more strengthening. At the same time, kind of anchoring where to means the anchor, they also need to be understand with the help of the FEM analysis. So all those studies are the part of the floating system, not generally in the case of unwanted systems. These are the different type of anchoring which can be possible.
Mr. Chandok, if you can conclude, because we have the time issue, please conclude as early as possible.
Okay. So with respect to the anchoring, we can see the different type of anchoring on the piles, on the blocks, and different ways of installing the floaters. You can see that floaters can be installed basically in a different manner, whereby we need to have a mechanism for movement as well, and the electrical system can be also installed on the water bodies, like the sector inverters, drums, motors, all those things can be floated on the water body. Now coming to the studies, means characteristics with respect to the floater, we understand that with the help of floating solar, we are able to generate the higher generation, approximately 5%, owing to the lower temperature of the module due to cooling. This is also basically catch here that the moisture is very high, generally we get the lower distance compared to the ground mounted. Definitely saving on land and water is very important.
Mr. Chandok, you can discuss some of these issues during our panel discussions. I think you can conclude it, please.
Okay. And two important aspect I would like to mention here is that the supply chain constraint is very important. And second thing is that the selection of the material of this thing. Definitely, we will discuss it during the discussion. The raw material, choice of raw material, as well as the quality of raw material, and installing the floater production at the location itself, which will reduce the logistic cost, is very important aspect which we need to understand. This I will cover in during the discussion. We have also done the 2 megawatt of floating coil in Mauritius, which you can see in the Tamarind Reservoir. We feel that the site supervision and project management will come in March 24. And last slide, NTPC is already mandated with PMC assignment, and with this the value proposition, what we propose is that we are available for with a large pool of experts with the necessary assessment and feasibility for taking up the floating project across the globe. Thank you so much. Thank you so much.
Thank you. Thank you. First of all, many thanks to Mr. UK Bhattacharya, who has been the architect of many of this project. Many thanks for you to give the initial remarks, and also to Mr. Chandok to give a detailed presentation. And it's a 262 megawatt of floating solar is very important, which give a lot of confidence to the other countries. So what I would suggest, if Jaja is okay, we will have panel discussion followed by that. You would like to give the remarks. What would be better? Yeah. So I think we'll have the panel discussions first. Yeah. Okay. So I'll invite the panelists here physically to the dais. Take your chair here. Miss Techie Kaplan, please join the panel discussion, madam. Mr. Pankaj Kumar from Count Solar, Mr. Naveed Bandhu from the Mauritius Renewable Energy Agency. So we have the three panelists physically here. Mr. Chandok will be in the panel, who is there in the virtually. I hope Mr. Amit Singh, CEO of Adani Green Energy, also available virtually. Can you just confirm, Mr. Amit? Am I audible, Mr. Amit? Okay. Meanwhile, I'll just check up with Mr. Deepak Samuel, who is a senior scientist from NCSCM, the coastal management, who have done a lot of uh, the the center, who have done a lot of studies in Lakshadweep. Again, he is joining virtually. I hope Mr. Deepak is there. Mr. Deepak, am I audible?
You're audible. Can you hear me?
Yeah, I can hear you. Yeah, great. So we're just starting the panel discussion here. So let me start with Mr. Pankaj Kumar. I would like to, I mean, we have just gone through the presentation. The opportunities and challenges is given by the Dr. Mathur. I would request a question to you is
Mm.
what are the key technological advancements that are driving the reduction in cost and improving the performance of floating solar technology? Over to you, Mr. Pankaj.
Thank you. Thank you very much, Mr. Mesh. Uh, I think Dr. Mathur has shared a lot about the insights for all the developments which has taken place in the last couple of years. So, being a company with a technology background and thoroughly engaged in design, engineering, manufacturing of floating system, and also the installation of such big scale plants across India, I would just like to share few insights from our learnings. What I believe that there are few key technological advancements. I'll share that one is the evolution of PV modules, because now we can see that the capacity of PV modules is getting bigger and bigger as compared to 4 5 years ago. So with the same surface area, we are able to reap more benefits with a big module capacity. And so the advanced PV modules is enabling the floating solar to utilize the same surface area for better generation. That is one crucial takeaway. Second is about the advancement in uh, inverters, then high voltage equipments. It is getting more and more compact. So these kind of equipments, if we can place, which is happening now, we can place on the floating system itself. It helps in bringing down the cost of, say, the DC cables, the losses which happens because of the DC. So these things helps a lot, is helping a lot in reducing the cost and improving the operational efficiency. Another advancement, I believe that which has happened is the anchoring and mooring technology. After so many projects, so many learnings, so many insights, now the anchoring and mooring technology is so advanced that it is enabling installation of big scale projects in the deep water conditions. And so it is opening, you can see it is opening new avenues where thousands and thousands of dams and reservoirs which were having the deep water earlier, which was not easily accessible. Because of the advancement in anchoring and mooring technology, we can do these installations even in deep water conditions. Now, and one more thing, the water level variation is another key area which was not being touched earlier, few years back. Now, with more advancement and improvement in the design engineering of anchoring system, uh, now we can install the projects in water bodies which has huge water level variation. For example, we are doing one project in West Bengal, that's a pump hydro dam, and there the water level variation is 20 meters every single day around the year. So you can imagine the kind of engineering which is going into it, and once it is done, it will be like a engineering feat which we'll have achieved, and that will open another avenues, new avenues where we can go for deep water, more water level variations, and all these things which is possible now. So I think that these are the advancement which is happening now in floating solar.
Thank you, Mr. Pankaj. You talked about a very important point. If this 20 meters variation on daily basis, and you are able to generate power from the floating solar. It leaves lot of confidence for wherever such large variations can occur. So that's a great input. Many thanks, Mr. Pankaj. Uh, Now let me come to the other countries or in the region as a whole in Asia. So uh, many countries, including the small island countries in Asia, I think including Japan and Singapore, all are because of the constraints in the land. They are seeing one of the very uh, good alternative to go for floating solar. So it would be very great if Mr. K. Kaplan, who is from Asian PV Industrial Association, who is the Secretary General of PVR, so to uh, give your vision and the inputs or the experience in these countries. That will be a great learning for other countries to follow. Yeah, over to you, ma'am.
Thank you very much for this opportunity to be part of the discussion on floating solar. Um, all the ASEAN 5 countries, comprising Indonesia, Vietnam, Thailand, Philippines, and Singapore, and Malaysia, have very small land capacities. They were small countries, and yet all of their installation targets for 2030 up to 2050 are very ambitious. So the challenge here is how to scale up the installation and deployment of solar energy in their particular and respective jurisdictions, knowing that the land is going to be very limited. So the floating solar, and I'd like to more or less deviate from that, we would like to call it solar on water, because in our experience in the region, if we use the word floating solar, it only discusses a particular technology. If we elevate it into solar on water, then the prospect for expanding solar deployment opens a wider opportunity. And going back, so these are the very ambitious targets in Southeast Asia, and the land issue is very much limitation. So the biggest solar installation right now, the most recent one is Indonesia. They just commercialized it. It is a 152 megawatt installation on a dam in very close to Jakarta, and that has just been inaugurated. Before that, what Singapore, as you very well know, Singapore is a very small country, and so they are exploring water reservoir and have moved into offshore site as well. And their biggest installation right now is 60 megawatt. Now, prior to that was in Vietnam, again, another installation that's into the 35 megawatt. And before that, Malaysia, which is 15 megawatt, all floating solar, all in water reservoir. Now, in the Philippines, of which my company, uh, Sun Asia Energy, is developing 1,300 megawatt of floating solar on the biggest lake in the country. Now, in Southeast Asia, the three biggest lake are located in Indonesia, in Cambodia, and in the Philippines. Just to give you the context, in the Philippines, the biggest lake is 90,000 hectares. It can submerge the island of Singapore. Singapore is only 60,000. So that is how big the lake is.
Yeah.
Now the government has auctioned the resource to private developers, which started with 2,000 hectares of water surface. And so our company, Sun Asia Energy, has won the auction for 1,300. So we are the biggest developer. Now, there in sharing the experiences in ASEAN countries,
Yeah.
the variation is very important because these are on reservoirs and dam. In the Philippines, we have also one project which is going to be 100 megawatt on a water reservoir. And the variation is really big. And I think the advantages of knowing about how to customize the anchoring is going to help push forward the use of this dam. So the Asian Development Bank has forecasted for Philippines alone 22,000 megawatt potential floating solar, of which right now 2,000 is being developed. Here, the lake is very critical. Now, what have we done so far? In our test bed, we have discovered that the challenges in technology, one is that the floaters are very customized to a particular panel.
Yeah.
So if you use one panel, you cannot cross utilize it to another floater. I think that is one challenge because if you're developing large scale floating solar, there has got to be a standardized floater technology in order to allow scaling up of this particular
Yeah.
aspect. So that is one. The second of these floaters are the incline. Um, we started with 15 degrees, and the Philippines is visited by about 21 typhoons in a year.
Mm.
And so this has in our test bed, we have discovered that floaters with a lower incline is better because it goes with the waves of the lake of this size. Because then the wind matters in a lake like this. It's still freshwater lake. We're not still into a sea water where we don't have to deal with corrosion. But this is important because as the winds and the waves are moving very, very big during typhoon, then it matters because the floaters can flip over. And I think this is what happened in Japan, in Fukuyama,
Yeah.
where there was a big wave that happened. And so this again is the technology that has developed. Now, 5 degrees has another set of problems based on our test bed because that means you've got to use divers already for the O&M, for the operation maintenance, because the wiring will be different and the configuration of the electrical systems will be more of a challenge. It is possible, but then you have to have a different set of O&M protocol. And so these are the learnings that we have gotten. And what is important here, and I think this was mentioned earlier by in the opening remarks, is that by pulling all of these experiences together under
Yeah.
the ambit of ISA,
Yeah.
will give confidence to the insurers and the bankers that the industry is addressing all of this technological challenge because there are solutions to all of these challenges. And I believe it is important to educate the funders and the insurers that solar on a lake as big as the one we're developing will have a different set of challenges as solar in the water reservoir. So that is insofar as the technology is concerned. I've not yet gone into the environmental aspect of it because definitely the environmental requirements for a floating solar on a reservoir will be very different from a live lake where
Yeah.
there is biodiversity, where there is multiple uses of the lake, where you have fishing that's going on, where you have to take issue of navigational lanes for the fishermen, where you have to also take cognizance of biodiversity because of the penetration of the sun into seaweeds and all of that. So I think there are enough information for us and ISA to gather so that we can then make a case of how floating solar can then be funded, not in the scale of less than 100, but in the scale of a gigawatt of solar, like what we're developing right now. Asian Development Bank, which is based in Manila, is helping us do this. But I think it has to go through different parts of the country, especially in small states where water is going to be an important asset to be a developer for these small states to deploy and reach their ambitious target by 2030 and 2040. So thank you.
So many thanks, Ms. Kaplan. So, I mean, you have touched upon many important parameters, including the hurricane or the typhoon effect, because these are the many questions, these challenges, because as we go ahead, we may not have very comfortable water bodies, which is you will come across all kind of issues. These solutions gives a lot of confidence, industry as a whole, technology as a whole. So many thanks for that. And then the ISA's one of the main objective is to share all together, and so that the every the aspect of that, including the funding community, gets the confidence so that these projects can be scaled up. Many thanks for your inputs. Now, uh, with that, taking further from you, because some of the environmental issues, very in one of the countries where questions were whether if you put the floating solar, one of the very important issues comes is in the marine life. Will it affect that? And because the fishing is also is very important for the people there, and then such projects should not hinder the whole of their livelihood. So because of that, in one of our countries were asking about I mean, they were apprehensive about scaling floating solar. So, in this context, we have Mr. Deepak Samuel. Samuel is from NCSCM, who is that is the National Center for Sustainable Coastal Management, based in Chennai. So, they have done a very detailed study how it affects the marine life and flora and fauna in those areas. So I have Mr. Deepak who has joined virtually because of the flooding in some of those areas because of the continuous rains there. Can I reach out to Mr. Deepak? Are you available? I would like to reach out to you to share your experience based on the studies which you have done in the Lakshadweep, which is in the Indian Ocean. If you can share the experience so that that gives a lot of inputs and confidence for the other countries, also similar conditions who are facing such questions
No,
and your input on that. Yeah, over to you, Mr.
we
Deepak.
did some studies. Yeah.
Mr. Deepak, are you there? Can you speak?
Am
Yeah, please go ahead.
Can you hear me?
Yeah, please go ahead, Mr. Deepak.
Okay, actually, I will first of all thank the IS International Solar Alliance, especially Ramesh sir, to have invited us. And basically, I'm sharing about the experience.
Mhm.
Pointed
Yeah, there is some interruption. Yeah.
community perception and their the fishing phase. It's a fishing ground. All wetlands, for example, are important used for various other. This exercise with the community.
It's a problem there. Yeah.
It was 50-50. Some of them were, because the use of diesel generators in that was very high. So the deployment help out in the clean air of the environment. So some community people were very much for it, but some were traditional
They're missing.
groups, any kind of illegal activities. these areas are suitable for development of these SPVs. And we also found out that as there are different management plans available for the islands of Lakshadweep. These are called as integrated island management plans. And in the IEMPs, there are very specific areas demarcated as conservation areas and preservation areas. And there are also areas allotted as natural and traditional fishing grounds should be avoided. And when we did the plan for safety, we made sure that these ecologically sensitive areas, community fishing grounds, and all other sensitivities that are associated in the installation site are kind of met, and we made sure that the entire cable lining itself was rerouted. We did not touch any sensitive areas or the fishing grounds, and we rerouted the entire cable lining. So that was one approach that we did, and I'm very happy to say that the ministry has cleared that, and it's going to be one of the first projects in the coastal area and to go ahead. The major issue is that in terms of the coastal areas, the presence of high salt content has to be completely checked out because it might definitely impact our installations. And second thing is that there are birds that come very regularly to the installations very close to the coastal area, and the droppings of the birds can also cause the 100% functionality of the solar panels might increase because of the presence of these droppings and the solar crust formation on the solar. So how are we going to maintain that is one question we have to say. And with the fresh water. In islands, basically, they have very little fresh water. This is one area probably where we have to really think and find out how maintenance can happen. So that's it from my side. I'm very sorry because my internet is out, and in Chennai we have floods, and I'm just speaking to my mobile internet. Thank you for the opportunity.
Thank you, Mr. Deepak. Even though we couldn't hear you fully, but some of the important points which you have brought out, we could understand. So, this the some of these issues which you have brought out, like avoiding the sensitive areas, or the where the fish will be mutilated, or such areas can be avoided. Maybe these are the aspects, so that calls for specific assessment of those areas where the floating solar. I think that is the key thing which you have talked about it. Many thanks for that. But I think most of the things can have the remedies so that we can scale up floating solar if we take care of the important aspects which you talked about. Many thanks, Mr. Deepak. So
Thank you
taking
so much.
forward, Mauritius is one of the island countries, and you have the issue of the land, and then so the floating solar will be very promising to you, and you have already taken up some of the projects. So my question to Mr. Naveed Bandhu, thank you for coming here, and please share your the experience so far, because I think you are started the process of one of the project 3.5 megawatt. What are the challenges so far, so that we are able to address those issues and then give some valuable input so that you are able to successfully complete it, and then the scaling up. Over to you, Mr.
Thank you very much. It is a pleasure to be in your midst today to discuss a topic of great importance. Let me first, at the outset, tell you that the prospect of utilizing water bodies for energy generation is just not an option nowadays. It is a strategic imperative, at least for the case of Mauritius. One of the just at the beginning, Mauritius is a tropical island just below the equator, and we are visited every year, 5 to 6 months, by cyclones. So one underlying parameter that we need to observe is that all panels, whether it is floating solar, ground mounted, or rooftop, they need to be able to withstand wind speed or gusts of 280 kilometers per hour over 3 seconds. That's not only the panels, also the floaters as well. So floating solar as a, we can consider it as a new technology. At least for us in Mauritius, we are most familiar with ground mounted and rooftop. We would require lots of collaboration or partnership with other countries, at least to learn of other case studies or lessons learned, so as they can help us when it comes to, let's say, for anchoring, for mooring of panels.
Yeah.
Because it is important to note that all water bodies in Mauritius have their own specificities. In 2019, we have Marina, the Mauritius Renewable Energy Agency, has commissioned an island-wide feasibility study for Mauritius, and we have identified a potential of 700 megawatts on 11 water bodies. And in 2020, the government has announced a 2 megawatt floating solar at Tamarin Falls. Our friend from NTPC has touched on that a few minutes ago.
Yeah.
I am made to understand that for the floating solar of 2 megawatt, it is currently at the evaluation stage. So we hope to know more from our colleagues from CCEB very soon. It is also very important to highlight that we also have a dry season. So the positioning of floating solars in wherever in Mauritius is important so that during the dry season it is not distorted, and the generation is to remain more or less the same. And now, when it comes to collaboration partnership, it is important to highlight that in Mauritius we don't have the right skills, the right manpower for any kind of assessment, whether it is like the wave action analysis, the fatigue tests, the assessment of sedimentation level of reservoirs. There's a list of tests that we have to carry out prior to any commissioning of FPV. So we hope with the help of ISA here, we meet lots of people from the fraternity and to be able to help us in Mauritius. And in the RE roadmap that we have reviewed in 2022, there's a deployment of 32 megawatts earmarked by 2030, and right now the 2 megawatts is in the evaluation stage, and the 30 megawatt also will be soon take shape. Thank you.
Thank you. Many thanks, Mr. Bandhu, for giving those details. And we hope ISA, of course, NTPC also is helping you in as a consultant to develop this the first floating solar project. Many thanks for your inputs. I think this collaboration should we should take it forward. Yeah. I think the Mr. Amit Singh is not available with us, who couldn't join probably. So I'll reach out to Mr. Chandok as our last panelist. He has already given a presentation. So, Mr. Chandok, based on the discussions and some of the points which you talked about, if you can briefly touch upon the important parameters which you will be looking for, so that that creates the feasibility studies completed for any projects. If you can share those important parameters, and especially on the Mauritius. So in the pause of time, please make it very brief. Over to you, Mr. Chandok.
Yeah, thank you, Mr. Ramesh, and thank you so much for giving this opportunity. The most important aspect with respect to the floating solar, the kind of technological barrier, if you can say, in the corrective measure, what we need to take forward is basically the mold material, the floating material, the floaters material. This we learned from our various pilot scale installations. We found that the material is basically going to last 25 years, as we all know. At the same time, the kind of quality for that floating material is very, very important. You can say the used material with the floating material is very, very common. It is very important to have a quality standards for this floating material, so that we can basically have life of 25 years established. That's the kind of a excellent aging testing for this material. What I could perceive from the discussions, and at the same time kind of explanation which we have, the limited supplier. At the same time, kind of engineering design which is required, type of basically getting the material as well as their stability in the water bodies for a wind velocity of like 80 kilometer per hour, which was mentioned by our colleague from Mauritius. These are very important that we should have a very established engineering design for that find out the kind of weaker points in the floater and kind of a anchoring which we should place. The second important aspect is that when we are going for a feasibility study of floating material, floating systems, the location as well as kind of cost involved in that particular position is very important. Now you see when we are talking about the floater, these are basically you can say air balloons kind of a thing. If you are manufacturing at one location which is very far from your installations, other location, then the transportation cost is very huge. So the design as well as the manufacturing, if it can be done in the installation, it will reduce the logistic cost as well as transportation cost also. So we have to make out some kind of a arrangement where the manufacturer of the floater can get machines and all those things. They can basically produce the floater of installation. The third important point is basically the anchoring mechanism. We have already seen that we have installed the water floaters on the very controlled environment where basically the reservoirs having much variation. There would be several projects which are coming up, which are basically associated with the hydro project. Here, the water bodies at the same time the level of water variation will be huge, like 5 and 30 meter. At the same time, there could be a possibility that the whole water will go out. We have to have some arrangement for that as well. So those type of challenges which we need to establish, the kind of a free anchoring mechanism basically sustains dynamics of the water level should be introduced. Require the R&D, research and development in these aspects. These are the very important aspects we should look into going for such type of project. Thank you.
Thank you very much, Mr. Chandok. And you have touched upon very important parameters, including one very important thing. I think the floater design and which you talked about, the local employment, people can be engaged in the assembly of the floaters, so that a sense of involvement from the local community also comes when the floaters are assembled near the project site. Many thanks for sharing this information. I think with that, because we are running out of time, because of the paucity of time, I think we will conclude this panel discussion. And I would request Mr. Jajia to give the remarks on behalf of the Honorable Minister from Mauritius before we conclude this session. Yeah, over to Mr. Jajia. If you can be here, so
Dr. Ajay Mathur, DG ISA, Excellencies, distinguished guests, all protocols observed. Good morning. My apology for being a bit late to this event. It gives me immense pleasure to be in your midst today in the context of this event. Scaling of floating solar PV, I wish to express my heartfelt appreciation to ISA for the special invitation to Mauritius to participate in this dialogue. We highly commend this initiative to allow countries, particularly small islands and other developing countries, to contribute to this discussion and to have their own perspective on the adoption of floating PV. Ladies and gentlemen, as I said, we are the most vulnerable when it comes to the impact of climate change. Mauritius is already facing the impact of climate change, manifesting itself in the several ways, including prolonged droughts, intense cyclones, and flash floods. I must emphasize that Mauritius' contribution in the global GHG emission is hardly about 0.01%. Yet we are facing all the scourge of global climate change. Despite all the efforts that we are undertaking and implementing, given our size and contribution to mitigate the GHG emissions, we will continue to face the adverse impact of climate change. In Mauritius, we have already developed a roadmap to achieve 60% renewable energy in our electricity mix and the phasing out of coal by 2030. In 2022, last year, the contribution of OE in the electricity mix was 20%. The roadmap focuses mostly on solar, wind, and biomass energy production in the short to medium term. Given the intermittency of solar and wind, forthcoming projects in these renewables are now called to be combined with battery energy storage to contribute to the base load. Given its accessibility, reliability, and affordability, it is no doubt that solar energy will continue to be an important renewable energy source in the short to long term. Ladies and gentlemen, as an island state, the major constraint, as already highlighted here by the panel, is limited land availability. Next is financial capability and also as highlighted by my friends, technical know-how to implement those new technologies. In Mauritius, we have already implemented 10 utility-scale solar projects, and we are now facing the difficulty to implement new projects due to scarcity of land as a result of competing use from other socio-economic development, hotels, smart cities, housings, and agricultural use. Furthermore, implementing utility-scale projects locks the land for a period of 25 years, means we can't do any other activities. In this context, to optimize the use of land, Mauritius is contemplating the adoption of floating solar PV and agri-PV. Following an island-wide feasibility study on the potential of FPV carried out by Marina in collaboration with the UNDP in 2020, a potential of about 700 megawatt was identified in 11 of our major reservoirs. This will also contribute in the reduction of evaporation from the reservoirs, mitigating our vulnerability to climate change. Considering a 50% coverage, 350 megawatt could be generated, which represents 75% of our peak demand. Mauritius has already embarked on a 2 megawatt pilot floating PV, which will be scaled up to 32 megawatt shortly. This project will be combined in the medium term to long term with battery energy storage for stability of the grid. I must say successful implementation of this project will also give the way to the possibility of implementing a pumped hydro storage scheme at that particular location. We have also noted that some islands like Maldives, Seychelles, they have implemented offshore floating PV. However, these islands are not prone to cyclonic conditions unlike Mauritius, which is located in the tropical zone. Mauritius has an exclusive economic zone of about 2.3 million square kilometers. Studies will have to be carried out to investigate into the feasibility of implementing FPV in our exclusive economic zone. Such studies will have to look into critical aspects such as dam safety, water quality, ecological environment, depth of water, and sedimentation. Ladies and gentlemen, with these few words, I conclude. Okay.
Thank you, Mr. Jajia, for delivering the speech on behalf of the Honorable Minister of Energy from Mauritius. So I'm at this point, I would like to welcome Honorable Minister of Energy from Malawi, His Excellency Ibrahim Matola. Welcome, sir. And we had a very good discussion around the floating solar today. And we had eminent panelists from various parts from the Asian region, from Mauritius or Lakshadweep, and all kind of different situations where the floating solar is the possibility. So at this moment, I would request you to share your vision and thoughts on this very important topic on floating solar. Over to you, sir.
All protocol observed. Let me thank the speakers who have shared the country experience and on how they are faring on the floating solar projects. When you look at Africa and the Caribbean and the Pacific region, we have similarities in terms of geography and also weather pattern. Most of our countries are agro-based. Hence, we have challenges of land, which becomes very difficult to implement some of the projects, especially on solar. Malawi is agro-based, but also has got a lack, which means that there are advantages and disadvantages. But the advantages are more when it comes to floating solar. What we need as Africa, when you look at India 40 years ago, we just close our eyes and open. You'll see that 40 years ago, India was like Africa, but they invested a lot in education, science, innovation, which made them to leave us behind. So this era, when we're talking about floating solar, we need to invest a lot in technology. Human development is very, very important. One, we should change our curriculum, where most of African countries, the curriculum is still the outdated one, where we are forced to learn which is the tallest mountain in Africa, which is the longest river in Africa, how many parts of a frog. All these things they are not relevant with the current situation. But we need to invest in technology so that we can advance the development of our countries. For those countries which are having agriculture, like Malawi, as I've given an example, land will be an issue, and most of the money will go in compensations. Without even implementing the project, most of the money goes on compensation because you have to move farmers into other areas. But now there is an opportunity. For example, the speaker who was holding the floor from Mauritius, Seychelles, Madagascar, Tanzania, Kenya, that side of Mombasa or near the Indian Ocean, where they can invest a lot without tampering the agriculture, but they can invest a lot in floating solar. The advantage of this is that the evaporation will be reduced when we have floating solar. But also, the vandalism which is taking place in most of the countries in terms of this infrastructure, it will be minimized because they cannot go to the deep waters, those who are vandalizing the infrastructure. We are paying a lot of money in order to put back the infrastructure of solar. And also, the disadvantage which is there, where we can put our resources together and share the knowledge and the experience with other countries who are also having this project, is that the fishing industry would want not be to be disturbed. But also the tourism, like in Mauritius, Seychelles, where the boat cruises would want also to be using the waters. So it needs also to share the experience and how we can do it together without leaving anybody behind. This issue of renewable energies doesn't need one country. We need to do it together. As I always say that one hand cannot clap. اليد واحد لا تصفق. We need concerted effort. Developing countries to pump in a lot of money so that we can minimize the issues of immigration. People are moving from Africa into other regions of the world in order for green pastures. But this can be reduced when we invest a lot in Africa region, because we have seen what has happened during the COVID, where the movement of goods and services, movement of human development or human capital was restricted. So once we put our factories, is that we are going also to create jobs in Africa. But good advantage is that with the connections, the interconnections which can be there, Africa is so blessed with abundant sunlight. Africa is so blessed with abundant wind. But when we are talking about sun, these are uninterrupted sources of energy. When you look at oil and gas, there is a monopoly, there is energy security, but the sunlight, no matter how powerful the nations can be, the other nation cannot block the other nation not to have sunlight. This is the way to go. And this COP28, especially with the championship of Prime Minister Modi and also ISA, I would like to move a motion that this COP should not be a talk show, but it should be a COP for action. And the developing countries should inject a lot of money into Africa, where the abundant resources of energy, clean energy are. And Africa can put that power into other continents. I thank you very much, and I wish all the best. And this COP, let it be COP of action, not talk show.
Honorable Minister, the passion by which you talk, we are always very excited to listen to you. Many thanks for your sharing your thoughts, and I hope the message is taken by all of us uh, to make it a action-oriented event, so that tomorrow we are able to focus on the execution on the ground, so that the things move. Many thanks for sharing sharing your thoughts. So I think we had a wonderful session. We had a wonderful panelist. Honorable Minister will share all those learnings and various aspects, including the environment point of view, the advantages, the issues. All these things will compile from our learnings today. After all, the ISA's job also is to assimilate all the information, so that it brings confidence to the countries where we can scale it up. So many thanks. Honorable Minister will share all those things. Uh, with that, I would like to conclude this session, and I would like to thank all the panelists for coming over here. And also, I would like to thank the many of them virtually, because of the some logistics issues. They could not come, including floods in some of the areas. Some of the airports were closed. Uh, but we had a wonderful discussion, and thanks to the technology, even if you are not there physically, at times you can always be virtual, so that the messages or the sharing of information happens. So many thanks for all the panels and the honorable minister. I would also like to have a small token of our appreciation for today's session. Yeah. check photos. Yeah, sure. Yeah. I just initiate after. Because I'm getting to hear you. Go, really nice. Thank you. Oh, thank you.